All right, your next lab, let me jump out. If you go inside the lab03 directory, there should be a pointers.txt. You open that up, it's going to be a lab 3 on pointers. I'm going to give you some, excuse me. Basically, I just say, hey, pretend this stuff is on the stack. And you are to always assume that a previous line of code is executed. So every piece of code that you write here, you assume has occurred when you start writing down here. And this is going to be very important for certain questions. So notice I have x on the stack. AR sub 5 is an array of integers on the stack. I did not show you that, so let me show you that right now. Okay. What you have to understand, and it's a little confusing, is since you have the double brackets, ARY is a pointer. What is it pointing to? I like the bar there, but it's confusing. It's pointing to 5 integers that are also allocated on the stack. So you have 5 ints right here, and it's pointing directly to there. Okay? All right? That's all that's happening. What's nice about this is with this syntax, when your function returns, it automatically deallocates it. So you just created 5 integers on the stack. Are we good with this, or do you need me to write something else? Good? All right. And it already has those values? Good. So let me go ahead and actually put that in there on this picture for you. What was it? It said it had values in there. I forgot what they were. 0, 10. Okay, good. All right. Sub 0 is 0, sub 1 is 10, sub 2, so forth and so on. Notice that that sub is really just jumping down the number of bytes. All right, so declare a pointer P1 that initially is pointing to X. All right, hopefully y'all should be able to do that. Change the value of X to 63 without using X, aka use the pointer you just created instead. Declare pointer P2 pointing to the first item in ARR. All right. Change the first item in ARR to 7 without using ARR, aka use the pointer you just created. Change the second value to 20 using the solid brackets without using ARR, aka use the solid brackets on your pointer instead. Change the fourth, 35, again, I guess using the solid brackets, without using the solid brackets, without using ARR. Okay, we did not go through this. So let me show you the other syntax. That's why I go through these labs. All right. Let's see. So we're going to go ahead and do it this way anyways. We're going to make 3. All right. So, and doop, doop. Oh, it is burning. So ARY sub 0. All right, just make sure everyone's on the same page. What value should that print out?
55.
55. Let's go ahead and compile it just to make sure. 55. Beautiful. Let's go ahead and get rid of this. Okay. What should this print out? Ignore that command right there. My question is, what's this going to print out?
The memory address of the first
Ah,
number there, right?
not the memory address. That would be ARY, right? Let's go ahead and step back. What you're thinking is this, and that'll be the memory address. So that's the memory address of ARY. Okay. And then if we dereference it, now what is it going to be? I'll go ahead and get rid of that in case that's confusing you.
First number of ARY?
Correct, because we jumped to ARY and we're printing off the first number. Still 55. Notice we have two syntaxes that do the exact same thing. They do the exact same thing. They're logically equivalent. Okay. Hey, look, we can add to a pointer. What is that going to do? Oh, hold on. What's ARY plus 1? You're on the right track. It goes to the second element, but what is it going to print out?
The memory address of
The
second.
memory address of the second element. So notice 770774. Why did it go down 4 bytes? Because it's an integer. Very important. When you do your pointer arithmetic, I highly recommend putting parentheses around it. Now what is it going to print out? That last one's going to print out
The next element.
the value of the next element, which I think was 78. Is that right? 78. Perfect. And just in case some of you are not a little off, what's that one going to print out? 78. Just so you know. Oh, thank you, whoever did that. Whoop. This is a shorthand for that. Okay? This is actually a convenience of actually what's going on, which is right here. All right? And now to just take this one step further. Oops. What's that going to print out? We'll go ahead and start here. P2, it's a pointer, and holds the memory address of ARY. Yep. P2, what do we do on this one?
We're adding 1.
We're adding 1, which does what to the pointer?
Changes
Yeah, right? We add 1. So semantically, what is it doing? What?
Goes to the next point?
Goes to the next. Ooh, that's an interesting way of doing it. Goes to the next pointer. Sure, all right. Points. P2 now points to the next element of ARY. So, star P2, what's it going to print out? Not the 55, but 78, because that pointer jumped over to the next one. Okay? So remember, a pointer is a variable, so you can manipulate it, add to it, subtract to it, and set it all you want as well. All right. So when I say change the fourth value of 30 in AR to 35 without using the brackets, you're going to be using that syntax I just went over where you're in the parentheses adding something and then dereferencing. Change P2 to point to the second item in AR without using ARR. Okay, AK, you're going to have to add something to it, or subtract, I guess, depending on what happens. Change the value pointed to P2 by 77. Keep track of what values those are. All right, and I think that kind of ends section 1. Number 9 is where I'm going to have you start thinking about this. This is where you got to start coming up with the syntax. Write a Boolean expression that returns true if and only if P1 and P2 are pointing to an equivalent value. So if the values the two are pointing to are equivalent, not that they're pointing to the same value, just that the values that they're pointing to are equivalent. All right? That's hopefully different because see if P1 and P2 are pointing to the exact same location. These are not the same Boolean expressions. This one is asking if the two values they're pointing to are the same. This is asking are they pointing to the same value. If that's not clear, you could have two variables that hold the value 7. And therefore, if you had a pointer to each of them and you dereference it, they would point to the same, what they're pointing to has the same value. But the two pointers are pointing to something different, even though they're both pointing to the value of 7. Whew. Make P1 point to a dynamically allocated integer, aka an integer that is allocated on the heap. We went through that syntax earlier. Make sure you free it. And then make it point to an allocated array of x integers. Again, create the array with new, and then free it. All right. Notice that, let's see. I deleted I here because I only had one integer. Earlier when I had star I equals new int of b variables, I'd have to do this. Because now, since it's an array, it needs to know to, whoops, the better syntax is that. It needs to know to delete it. And it did not like that. Because I tried to dereference I, and that makes no sense. There we go, much better. Okay. All right, down here, I'm going to let y'all look into it. In this code, they put parentheses around the int. That's perfectly fine. That's like what I did earlier with no parentheses around it. And you're just need to read that and tell me if you can figure out any issues that might be wrong with the code. So describe the difference between statically, the stack, heap, and why does C++ support both types? Hopefully you can at least give me some answer there. It is not going to be due September 9th. It should be due a week from today, which is what? 16th. The 16th. Thank you very much. Any questions? No questions, or?
It's mostly just that the lab 3 is not currently in our directory.
Oh, I will add that.
Okay.
Add that shortly.
Okay.
I must not have pushed that. Oh, wait. Or did I? Let me find out.
Yeah, it's already in.
It's all, okay, then you forgot to do a pull from upstream. I'll help you with that later. Okay. Oh, yeah. Any other questions?